In this session, we're going to be talking you through using the Runtime SDK for Java for writing your own applications, JavaFX applications as it is. I'm Mark Baird, and I'm joined with my colleague Tyler, and we're both members of the Runtime team. Now, before I get started, I just want to get a feel for who we've got in the room. So, who in the room is completely new to the Runtime and never written a Runtime application before? A few of you, that's good. I think we're pitching this more or less the right level. And what about users of our previous 10.2.4 or earlier SDKs, maybe looking to migrate? So there's a few of you in the room here. And have we got any engine developers who are looking to migrate their applications over to Runtime? Not at all. That is encouraging. Okay. And what about users of the current 100 series releases? There's a few of you. So there's a good mix of people in the room here. So to give you a flavour, what we're going to be doing here is going to be taking you through getting started with the latest version of our SDK, which is 100.2.1. We released that a couple of weeks ago. And we're looking here at writing JavaFX applications. So I'll be taking you through the key classes that you're going to be working with to construct these applications. So here I'm talking about working with maps and layers and graphics overlays, and we'll introduce some of the new Java 8 programming concepts like lambdas and streams as well. Now, we'll give you a little bit of an overview of the offline data capabilities that we have in our SDK, but I won't go into a huge amount of detail there because there are some complete sessions on exactly that subject covered for all of the Runtime SDK. So I'll give you a flavour so you know what the capabilities are. I'll talk about the licensing and deployment operations you need to go through so you can get your applications to go live to market. And then I'll finish off by just sort of introducing you to some of the implications of Java 9, which is the latest version of Java which has come out, which you do need to be aware of these in moving your applications from maybe Java 8 into Java 9. And then we'll take questions at the end. Okay, so if you're new to the SDK, the best place to get started is to go to our developers website. So I'll just flip over to a browser so we can take a guided tour of that. So this, the landing page to developers.arcgis.com has links to all of our main developer technologies. The one that we're interested in here is the Java SDK. So the landing page has got an indication of what the key capabilities are inside our application. The guide tab is probably the most useful area. So what we've done here is we've written a number of step-by-step guides to explain how to put certain common areas of functionality, common use cases into your own applications. So you may be interested in routing or getting directions in your applications. And we've also got some getting started guides here. So the guide here on developing your first map app with Gradle would be a very good point to start if you've never written a JavaFX application before. So this gives you a step-by-step guide on how to get that basic map into your own application. All of the API reference is available in the web page, and it's fully searchable as well. But it's also worth saying that the SDK does include the java.jar, so the API reference can be visible inside your IDE of choice as well, so you don't have to go to the web page to view that. And then to complement the guide documentation, we have a number of sample applications that we've written, again, covering common use cases that you'll want to put into your own applications, but these are in the context of fully functional applications. So we've got a number of different areas here categorized. You might just want to do something simple like display a map, and we've got sort of a description of what you're doing in the sample code there as well. We've also got all of this code in GitHub, so you could just go into GitHub and clone the repository and be able to run the applications without having to cut and paste the code from our web page here. And then it's also worth noting that we've got a forum page in our community here, so if you've got any questions on the SDK, then you can post them here and some knowledgeable person may come up with some answers there. So just going back to the slides. So we mentioned there's a few people in the room here who've been using the previous version, the 10.2x. So when you get hold of the latest version, the first thing you'll notice is actually no longer an install. There isn't a setup.exe, which is actually, in retrospect, a slightly unusual way of distributing a Java SDK. So the SDK is now available in two ways. So we have a zip or a tarred gunzip file that contains all of the files required that you can wire up inside your IDE to make it work. So this works nicely for people who worked in an air-gapped environment, for example. But I would see that the majority of people nowadays making use of the fact that we store all the files you need in a Maven repository. So you'll be able to use a Gradle script to manage your dependencies and automatically bring all of that information into your IDE so your applications will just work. And to assist with that process, we've also got a Gradle, or if you prefer Maven, a Maven plugin as well. So just to give you a sort of a little bit of an introduction to Gradle build scripting, I'm not going to go into this in huge amounts of depth. I'll just highlight the main things that you'll need to add into a typical Gradle build script to get yourself running in a Java runtime app. So the first thing you need to do is point to the our Maven repository, which we store all the files we require in bin tray. And then you need to put in a line here that references the plugin. So what the plugin does is it goes off and it'll fetch the other files that you need in order to run the application. Because we're not writing a pure Java application here. The runtime is actually built on a common C++ core, which means that you get consistent functionality across all of the different APIs. So if you design an application to render in a specific way in a Java application, for example, you could actually port that so that it worked on an Android or an iPhone application and it would render in exactly the same way. So you need the libraries inside your application to make it work. So the plugin will actually go and fetch these things. And then finally, you specify the version of the SDK at the bottom. And then it builds and you've got an application. So let's just take a look at some of the key classes that you'll be working with. So those of you who previously worked with the 10.2x releases will be familiar with the JMap. This is one big all-encompassing class that you would put into your application, and it was the swing component to move forward. But now we've gone forward and we're supporting JavaFX. We've actually broken this down to enable you to be able to write model view controller style applications much easier. So the presentational side of things will be put into the map view. So this is the JavaFX control that you put into your application, maybe using FXML, that you'll visualize and you'll interact with in order to be able to look at your data. But the actual data that you're visualizing is specified in a separate class, which is called the map. Well, we called it the ArcGIS map in Java because obviously the map is used elsewhere fairly intensively. And what the map class does is it specifies the base map. So this is the wallpaper for your application. So it could be some nice looking National Geographic data, for example. And on top of that, you add your operational layers. So this is your business data, which may come from a feature service in ArcGIS Online, or it could be a WMS service, for example. So this is your data that you put on top of the base map. Now, as well as being able to write 2D applications, you can also visualize your data in 3D. And it's actually very simple. So rather than working with a map and a map view, you can actually just swap those out with a scene and a scene view. So the scene view control, again, it's your JavaFX control that you interact with inside your application. And then you specify the layers that you want to visualize inside your 3D application using the scene. Well, again, there's a JavaFX clash there, so we actually called it the ArcGIS scene. The scene's actually very similar to a map. So it has a base map, and it has your operational layers, so your business data that you want to visualize inside your application. But we also have the concept of a surface. And what the surface does is it specifies the terrain. So it will enable you to be able to visualize the lumps and bumps that make up a mountain, so you can see your data in 3D. Now, before we actually dive into looking at any code, I wanted to introduce you to this state transition diagram. This is what we call the loadable pattern. And this is what we've actually implemented in the SDK for typically network resources. These are resources which are not necessarily going to be very fast to respond. Now, obviously, when you're writing an application, you don't want to be doing things like blocking your UI thread, waiting for some network response to come through, because users get frustrated with that. So what we do is we have a callback mechanism inside the API that fires when state changes of when the network resources you're working on change. So maybe you're working with a feature service which contains some spatial information that you're wanting to display in your application. When you first instantiate that class, it's in a not loaded state. And then when you start to interact with your map, internally we sort of go off to the service and start collecting the metadata and any associated information with that. So that is currently then goes into the loading state, and we fire a message to back to you to say that is actually happening. And then when everything's working in a satisfactory way and you're able to sort of get data from that and visualize that onto your map, it will go into the loaded state. So that's the point where you may unlock some functionality in your application for doing things like editing the data that you're working with. But things don't always work the way you want it to. So it may be that the service endpoint that you're going to collect your data, it doesn't work. Something's gone wrong with it. Maybe the network connection's broken. Maybe the server's gone down. You need to be able to inform your users that that has happened. So in this case, we would fire the state of failed to load. And you could do something like inform your user, say, well, the network's down. Have you tried reconnecting to the network? Or maybe you need to contact your administrator to make sure this service is sort of working properly. But you can give that feedback to your users without blocking the UI thread for waiting for that to happen. Okay, so what I'll do now is hand you over to Tyler, who's going to show you some of that theory in a simple 2D mapping application.
All right, thanks very much, Mark. Yeah, so for those of you who are not really familiar with writing JavaFX applications, this will show you a little overview of probably the simplest case you can come up with. So this is a single class application. Typically, you'd have a main class which extends the JavaFX application class, and then you overwrite this start method, getting a stage, which is basically the window from that operating system that you're targeting. This bit here is pretty standard JavaFX. It's just setting up the title and size of that window. And here's where we really get into the runtime SDK classes. So just like Mark was saying, we can create a map view control. This is based off of normal JavaFX controls. So you can add them into your layout just like any other JavaFX control. As we're doing here, we're adding that map view control to this stack pane. And then you have your ArcGIS map, which is really your data model that will be rendered in the map view. It's as easy as constructing this object. We have some default base maps that you can choose. You can also make one with a tiled layer from a tile service. And all we do is just set the map to the map view. Pretty straightforward. Now, in terms of getting data from a feature service, all we need to know is that URL to that feature service layer, and then we create a service feature table with that URL. Now, this is very similar to the ArcGIS map versus map view comparison, where the service feature table is basically the data model or the small database that holds all the features, and then the feature layer is what actually does the rendering. So you pass in that feature table to the feature layer, and then you add that as an operational layer, which means it will be rendered above the base map. Just like Mark was saying, call load async to load that. So I'll go ahead and run this demo just so you can see what this JavaFX app looks like. So we'll get that stage for the operating system, and then the map view will load. We have a base map, and then we have features from that feature service. Now, to go into more detail about the loadable pattern that Mark was talking about, I'm just going to actually fudge this URL a little bit so that it's no longer valid, and we're going to test to see what happens. I'll go ahead and run the app again. And we'll see that everything acts pretty gracefully and we don't see anything crashing. But notice the features are no longer rendering. So now that's probably not the best experience. You might want your users to know why that's not happening. And Mark alluded to it. We have a callback where we can look at this loadable state. And again, this pattern is throughout the API for any kind of asynchronous operation, where we can add this done loading listener callback and check if the load status failed, and then display an alert. So I'll go ahead and do that one last time. And we can see that this time we actually get an alert, and it actually gives us a handy message that's saying this URL is not valid. So that's a very basic introduction to a JavaFX app that uses our SDK and demonstrates maps, layers, and the loadable pattern. So I'll switch it back to you, Mark.
Okay. Go back to the thing. So one thing you'll notice here is that we're working with a map class, and Tyler was manually adding in the layers of information that you want to show inside your application. Another constructor for the map class enables you to be able to pass in a reference to a web map. So if you've already authored your map in a web map that you've got somewhere in ArcGIS Online, you can just make use of that, and it'll just inflate that map class for you, and it'll just work. Okay, so we're talking now a little bit about graphics overlays. So graphics overlays are quite useful, actually. You can use them for displaying temporary or fast-moving items. So typical use cases for these might be you want to stick a big red spot on the map to show where you are at this particular point in time. Or it may be that you're receiving a radio feed of the location of your co-workers out in the field, and you want to be able to show where those are on the map. Now, this kind of information isn't necessarily the sort of information you want to store inside a feature service, because it's backed by just a normal relational database. You don't necessarily want to be sort of firing in rapid updates into that. It's not going to update very quickly. So these data sets are very good for sort of fast-moving objects. Now, they can be used for displaying points, lines, or polygons, and they can actually be rendered in exactly the same way as the feature layers. So all the symbols and the renderers that you're familiar with also work with the graphics overlays. Now, it's worth noting that the graphics overlays, which used to be called graphics layers in the previous release, in case you're wondering, they're not part of the map or the scene. And the reason for that is that the data inside the graphics overlays is not persisted. You're responsible for the contents of that, so you need to work out your own location or listen into that radio feed to be able to put those dots on the map. So for that reason, it's actually part of the map view. Now, it's worth mentioning the draw order of everything which is rendered inside your map. So at the bottom of the stack, we'll always start off by rendering the base map. So this could be your National Geographic data, and then over the top of that, we draw our operational layers, and then the graphics layers get drawn on top of everything else. So I'll hand you over now to Tyler, who will give you a demonstration of graphics overlays.
All right, thanks again. So I have another JavaFX application to demonstrate these graphics overlays. This time, I'm setting up this new application pretty much the same way, except I'm using a scene view. And that's just to demonstrate how they're essentially the same kind of API. Creating the scene view this time and adding it to that stack pane, and then creating an ArcGIS scene, again with the same, one of these default base maps. So the pattern is exactly the same. I'm also going to add that exact same feature layer onto here. So those classes aren't different. You can use layers between the 2D or 3D versions. The new thing here is the graphics overlay. So we're adding that to the graphics overlay collection on the scene view. Again, not the scene, because none of this is persisted. And then how you make graphics to render is you create symbols. And I'm going to show a few different types of symbols that you can create. One is the simple marker symbol. So these ones are most common in like 2D cases. You can pick a style, such as this is basically the shape of the symbol, like a circle, square, a star, something like that. You give it a color and a size, and then to create the graphic, all you do is give it a location and that symbol that you want to render. And then you add that to the graphics collection of the graphics overlay. Another type of symbol that's used in scenes specifically is the simple marker scene symbol. And this one allows you to create 3D shapes such as cones, cubes, spheres, etc. So you can give that a few parameters, and again, give it a location and the symbol, and you can render it. Another option is to create model scene symbols. So this is actually using a 3D model, and we support a lot of 3D formats. So here I'm taking a file to a local model of the ISS. And I just realized I don't have that file on me. Yeah, so this will go to, this will load an FPX file. And then, yeah, giving it a location and that symbol, and it will, we'll add it to the graphics overlay. The last symbol that I want to show is called a distance composite scene symbol. So a distance composite scene symbol allows you to kind of mix different symbols together and set distance ranges from that symbol for how it should change based on your proximity to it. So you can actually have one symbol render when you're really close and another symbol render when you're far away. Again, it's the exact same way to add that. So we're going to run this, even though I know that symbol is missing, unfortunately. But it should still work. And we'll see that we zoomed into this symbol. And this is actually the simple marker symbol. And as we zoom in, we can actually see that it transitions to that cone symbol. And then what would be the ISS model, which is not there, unfortunately, would render at that scale.
I have another demo, actually, which I've just conjured up. So if I just switch over, just to show you the concept. So this isn't the International Space Station. This is another demonstration we've got. But it's a model symbol that we've got from a file in exactly the same way as Tyler did, but forgot to get the file. So as I'm zooming out, what I'm doing is I'm sort of changing the representation of that according to the distance. So it's turning into a cone now, because obviously that's more appropriate to look at that particular view scale. And then as I zoom out, if I can do that on my tracker pad, that will turn into a simple marker symbol. So this is exactly the same demo that Tyler had, but right. I'll switch back to your code there so we can show that.
And then the last thing I want to mention with this is that the simple marker symbols, you can see, they actually don't really depend on, at least the size stays the same at any level of detail, whereas the 3D symbols, they actually have a definite size within the scene, so they'll get smaller as you zoom out. Yeah, so that's a basic intro to graphics overlays and graphics. So I'll turn it back to you.
Okay, so we'll just go back to the slides. Now, all of the data sources we've been showing so far, apart from the graphics overlays, have been sources which come from online data sources. Now, we recognize that you may want to write applications which do data collection out in the field, where you don't necessarily have very good network connection, or you might not have any network connection at all. So I just want to give you an overview of the capabilities that we support for this. As I say, there are sessions later in the week to cover this subject in much more detail, but this is just an overview. So we cover two main patterns. So the first of which, it's probably the most commonly used, actually, is what's called the services patterns. This is where your data resides in a feature service, which could be hosted on ArcGIS Server or in ArcGIS Online, for example. And if you've configured that feature service so that it's what we call sync enabled, what you can do is you can go to that feature service and you can provide it with an extent. And you can say to the feature service, create me an offline version of this data. So the server will go ahead and it will create that, and you can download that and have it stored locally on your device and your PC, so that when you start up your application, when you're out in the field, rather than connecting to the online data source, you can connect to the local geodatabase, and you can visualize, and you can see the attributes, and you can even edit that data. And the code that you're going to be using is exactly the same. It's just the initial connection that's going to be different. So the editing code for online data is exactly the same as offline data, so we share the same API. Now, when you're back in an area of network connectivity at the end of the day, so maybe you're back in the office, you can actually synchronize the changes back into your feature service. So you're going to upload all the changes that you've made. But that's a two-way process. That synchronization will also download the changes that everybody else has made whilst you've been offline. So the end result is that your local geodatabase is now completely up to date for the area that you're going to be working in tomorrow when you go out into the field again. We also support another pattern for desktop users. So this is where you can author data using ArcMap, and you can create a package of data that you can again load onto your device, but this is just for visualizing data. So this is just for reference information you want to see whilst you're out in the field. So this doesn't offer any capabilities for editing the data and then synchronizing it back afterwards. If you want to do that, then the services pattern is the way forward. Okay. Next thing I want to give you a feeling for is 3D analysis. So this isn't new to the Runtime SDK. For many years, 10.2 and earlier users have been able to make use of a product called Local Server, and this has got access to a huge range of geoprocessing capabilities, some of which were quite slow, and line of sight and view shed are examples of that. So these are very processor-intensive operations. So when we actually run these in the CPU, they can take seconds. If you do a particularly big one, they can take minutes to do. And obviously, for the kind of applications you're going to be writing where the results of these calculations are important, then that sort of long delay to get the results back is not particularly satisfactory. So we've addressed that by rewriting these capabilities so that they're actually run as the local server. So rather than being CPU generated, we're actually making use of the GPU. Now, the architecture of the GPU enables us to be able to run a lot of the calculations for these operations in parallel. So consequently, we can get the results back instead of a few seconds, we can get them back in a few milliseconds, which is much more satisfactory. So I think probably this is best demonstrated by a real life demonstration, which Tyler's going to move over. Although I noticed you've got the International Space Station back now.
I thought I'd undo my embarrassment there and show you guys that we actually do support these different 3D models, and some of them with quite a bit of detail as well. So now I'll switch over to 3D analysis. So this is a little bit more complicated sample demonstrating line of sight analysis. So here, the lead up in the sample is essentially the same as we had in the previous sample. Create the scene view, add the scene. Here, instead of a feature layer, we're using an ArcGIS scene layer, which will allow you to render 3D buildings. So again, it's as simple as passing in the URL of that scene layer and then loading it. And then we also, this kind of introduces a surface, which is used to add elevation to that data. And again, there's just a service URL to get that elevation data. Creating a graphics overlay because we want to show some graphics. Here in this app, I have a route around the island of Manhattan that a boat is following. And so I'm going to get those route points And then I'm going to create some graphics at the top of some prominent buildings in New York City, one for the Empire State Building, One World Trade Center, and the Chrysler Building. And so I'm just creating some regular simple marker symbols on the top of those buildings. And then I'm going to create another one to represent the boat that's following that path. And then I'm going to set up the camera to show the whole island of Manhattan. Now this part is to do some animation of the boat along that path. And I won't go into too much detail on that for this presentation, but we do have samples on GitHub that show exactly how to do this yourself, so you can look into that if you're interested. Here's where you actually get into the 3D analysis. Just like graphics overlays are kind of non-persistent data above all your layers, an analysis overlay is very similar. We're doing this intensive GPU analysis on top of all of your data. So we create an analysis overlay, add it to the scene view, and then to create lines of sight between the boat and those buildings, as if we wanted to see if you could see them from a boat tour. It's as simple as creating this one object, GeoElement line of sight, from the boat to the building. And this will automatically handle tracking those graphics. So if they ever move, such as the boat is moving along a path, the line of sight will automatically adjust and you don't have to do anything to do that. The analysis overlay has an analyses collection, just like graphics overlay has a graphics collection. We just add those lines of sight and now they'll all render. The last thing that I want to say is that some of these analyses, you can actually get some kind of data back. And in this case, for line of sight, we can get the information on whether that target is actually visible. And we have a callback for that. So for each line of sight, I'm adding a callback for that target visibility changed event. And in that callback, I'm getting the target, which is that building. And whenever it's visible, I select that graphic. So you'll see that in the demo. I'll run this real quick. And then this is going to load a scene on Manhattan, and then the scene layer buildings will start rendering in. We can already see that there's some lines of sight from that boat, which is currently moving along the river. And these three buildings have graphics there. Now the lines are not obstructed right now because there's no buildings in the way. But once those start coming in, they will be obstructed and they'll turn red. That should happen fairly soon.
Just will the network to work a bit faster.
Exactly. Yeah. So notice that the boat is moving and the lines of sight are automatically adjusting there. Looks like it's about to go in front of a building there, and notice that the line of sight automatically switches to red. And then when it moves away and it becomes visible again, that callback fired, and then the graphic is selected on top of the One World Trade Center there. So this is a very nice analysis that many city planners use when they're designing a new building, and now you can use it with the Runtime SDK. So the next analysis that I want to show is viewshed. Here I have essentially same kind of app, except I have a different scene layer in Indianapolis. I'll skip over this part because we've looked at it in the previous app. But essentially, in this case, I have a tank graphic that's going to be driving around on the surface. To do that, you can set the surface placement of the graphics overlay to relative, and then just not give it a Z coordinate, and it will automatically kind of ride the surface for you. And here I'm creating that model scene symbol for the tank. And then GeoElement viewshed is just as easy to create. I can just pass in that graphic of the tank and then set up these other arguments giving a kind of field of view. So viewshed captures what you can see from an observed location, from a certain angle and distance, etc. And this will automatically track with that tank and show you exactly what it can see. And just like the line of sight, you add it to the analyses collection on the analysis overlay, and you'll see it rendering. So go ahead and run this real quick. And once the model loads, it'll attach to it. And then now we have a viewshed that's centered on that tank. I'm going to wait just a second for these buildings to load. It should happen much quicker than the other scene layer. Notice that this is the field of view of the viewshed. And then the green sections are what the tank would be able to see, and the red areas are what's obstructed. So this building is currently obstructing it. And I can just click to tell where this tank to drive. And notice that it's very fast calculating what areas are visible and what areas are obstructed. This exact sample and the code is all on GitHub for you to view and make yourself. So that's it for analyses. I'll turn it back to Mark.
Okay. This subject isn't quite as exciting, but I'll go through it. Essential. Go through now about how you license and deploy your application so you can get it to market. The first thing you need to establish when you've written an application, or hopefully before you've written the application, is the level of licensing you require for your application. So there are 4 levels, and I'm not going to go into the details of exactly what functionality is in each of those levels. I'm just going to talk about this from a technical point of view. So light is free to deploy, and then there are increasing levels of cost associated with basic, standard, and advanced. If you want to understand what levels of functionality are associated with those license levels, then there's a web page there that does explain that. So once you've established what level you have inside your application, hopefully it's light and it's free, you need to license your application. And there are 2 ways of actually achieving that programmatically. Now, the first of which is if you're a named user of an organization in ArcGIS Online. It's actually very convenient for your users because all you have to do is log in to that portal, and you can get hold of a license string which will unlock your application. But I realise that not everybody's a user of that platform. So if you're not, and you still obviously need to license your application, you need to make use of a license key. So the license keys are available from your local distributor if you're outside the United States, or customer services if you're within the United States. Talk about the license key to start with, because programmatically that's probably the easiest thing you can do. So this is the license string that I've got from customer services. It's quite long and goes off to the end, beyond the edge of the screen there. And all I'm doing here is I'm calling the set license on the ArcGIS Runtime Environment class. Now I need to do that before I actually make use of any of the functionality, the GIS functionality in my application. So you can see here, I've actually called it before I'm even launching my JavaFX application. So that's unlocked the ability to get rid of the watermark in your application, for example. So the other method of licensing your application is when you use your portal ID to log into your organization. Now the code that I'm showing here is just purely for convenience. I'm in no way endorsing that you should put your username and password into an application and then publish that out. You should probably use something like OAuth, but the code for OAuth is rather complicated and this is simple. So this is the only reason I'm using this. This is bad. However, if you ignore that, What I'm doing here is I'm creating myself a reference to a portal, so your organization.arcgis.com, and I'm passing in the credentials that I've hopefully acquired using OAuth, and then I just load my portal, and that'll go off and it'll get the metadata associated with my portal instance. And then hopefully that's worked successfully and my done loading listener will fire. I can then make use of the get license info method on the get portal info method on the portal class, and I get the license info class there. I can then turn that into a JSON string and then use that to unlock the application. So then you can start making use of your GIS functionality and you won't have a watermark in your application. Now, you might think there's a flaw in that because I've just been talking about applications that work offline. So how does that work? Well, you don't need to always log into the portal to use your application. So if you store this license, this JSON string somewhere locally on your device, that will work for a period of 30 days after you've collected it. So as long as your application can connect to your portal every 30 days, this licensing method will work for you. If you can't, then obviously you need to burn a license string into your application so that it works all of the time. So that's licensing. The next thing I want to talk about is deploying your application. So the typical workflow that you'll go through is you'll use your IDE of choice. Could be Eclipse or IntelliJ, seems to be most popular these days. And you'll compile that up to be a runnable jar file. And as you know, you can sort of run that in one of your platforms. So we support Windows, Linux, and Mac, and that application will run inside the JRE. But remember, we're not writing pure Java applications here. It's actually written on the C++ core. You've got to include the binaries that we've compiled for the SDK for it to run on those platforms. So if you're running it on Windows, you need to include the DLL file, and there's an SO file for Linux, and there's a dylib file for Mac. Or if you make yourself a deployment which has got all three of those, then you have an application that will work on Mac, Linux, or Windows, so it can be completely cross-platform. So to show that, we've got another demonstration from Tyler with a ready-made application.
All right, thanks, Mark. So one good example of how you might distribute your app is our own sample viewer that you can download from the developer site. So probably the simplest way to distribute your app is just as a zip file. There's many other ways to do that, but I think this demonstrates exactly what you need and nothing more. So in our sample viewer, I've just unzipped it here, and this is literally all it has. It has JNI libs, resources, some local data. This might be mobile map packages, tile packages, raster, whatever. And then your runnable jar, and this is your whole app. If we kind of step into the JNI libs, we can see the contents. We have DirectX, that's shaders for our windows. And then we have different folders for different operating systems. Now, if you're only targeting one specific platform, one OS, then you can actually just remove the other ones that you don't need and reduce the size of your distributable. But here, if you have all of these, then this exact application can be moved over to Windows, Mac, or Linux, and then it will all work. So those folders contains the dylib or the DLL, that kind of thing. Resources just contains some extra data used by the SDK, things like for localization, spatial reference projections, symbology, things like that. So that needs to go in your application as well. And those, if you put them at the root level with your jar, then the runtime can find them easily, and it'll just work. You can also set up an environment variable that will look for these if you don't want to put them in the exact same location as the jar. But provided you do all this, all you should have to do is double click on your runnable jar. And we'll see that the sample viewer will launch here. Here we go. And this JavaFX application is obviously styled for Windows. It has this window here. And then just to prove that that this still works and it was able to find the libs, we can run this sample that I was alluding to before. So this is kind of a plug for our sample viewer. It's definitely a great resource to find out more about how to create these applications. We have over about 80 samples. So definitely download this and give it a try.
And just to prove it does work with cross-platform, so Tyler was using a PC, I've got a Mac, exactly the same structure here, so they're looking in the JNI libs. People actually use 32-bit Windows, surprisingly. That does shock me, actually. But in this case, I'm looking at the OS X platform, and you can see I've got the compiled .lib file, which is what I'm running when I run my jar file, and I will fire up exactly the same application. It's styled slightly differently for the Mac, but essentially it looks exactly the same. So I can go and choose an application I like the look of. I prefer my airplane to your tank, and we can do some animation there. So exactly the same application working on any platform, including Windows 32-bit. Right, go forward. Right, Java 9. This is an exciting subject. It came about very quickly in December last year. And it's something we've been aware of for a while, actually. So when we were doing our 100.1 development, this is before Java 9 was released, we were actually testing our products against the beta releases of Java 9. And we needed to make some minor modifications to make that work. But it means that now Java 9 is officially supported. We've supported it since the November release we put out last year, 100.2, and obviously with the latest release we put out a couple of weeks ago. So if you go to download Java 8 now, the JDK 8, you'll see this message on the Oracle website. And basically, as of January next year, updates are no longer going to be available to Java SE 8. Is that a problem? Maybe if there's a security patch or security hole required as in Java SE 8, that could present you with a problem. So you're not going to be able to get an update from Oracle unless you're paying them some money. So Java 9 is the only way forward. Is there anything to worry about? Well, I've seen the use of Java in the runtime going back to Java 5, and we've gone over to 6 and 7 and 8, and all we've had to do is change the JDK, and it works, no problem. Java 9 comes along, that's probably not going to be the case. You do need to be a little bit concerned about this, and given that you've only got until January next year, potentially, before maybe a security problem comes along, you do need to take action. Your application is liable to need work, so it's worth testing it. You may just get away with it. So if the only API you're using is ours, then well, we've made it work. You're okay. But maybe you're using some internal APIs that start with sun dot something or other. You know you're not meant to use those, but they're actually going to be warnings that get fired in your applications when you run those against Java 9. It may be that in the next version of Java, they turn those warnings into runtime exceptions, so your app won't work, it will stop. JDEPS is a very good tool for actually doing a check for those internal APIs. And another thing you need to do is take a very close look at the third-party libraries that you make use of. So up until the release that we had in November last year, we were making extensive use of Controls FX inside the sample viewer that we're making use of. Now, Controls FX is brilliant. I'm a big advocate of it. It makes you produce very sort of nice, animated, modern-style applications. But unfortunately, there are two versions of Control FX, one which works with Java 8 and another one which works with Java 9. So if you want to write an application that works with both, at the moment, you've got a problem. We had a problem, and in order to make it work with both, we've had to back out of using Controls FX. maybe we'll bring that back in next year when Java 8 goes away and we actually make our API so that it works just against Java 9. Another area you'll come across inside Java 9 is modularization. So I will say that we haven't done anything with modularization just yet. So it's just one big component. I want to actually address that in a later release when we do a wider re-architecture of the runtime core, because the runtime core is actually getting quite large and we're actually looking at ways of breaking it down so that we can actually deliver it to you in smaller libraries, so you don't necessarily need all the functionality there. So to keep the footprint of your deployment down, this is particularly important for platforms like Android, we're going to try and break it down. So this is where we'll start making use of modularization going forward, but you're not going to see that from us for another year, I would say. So just a few words of warning for Java 9. It's definitely worth having a look to see whether your apps work correctly. So with that, I'll open the floor up for any questions. Hopefully that's giving you some understanding of what you can do with our product. Any questions? Yeah. So the question is, shall we just update to Java 9? I'd encourage you to try it out. You may not have any problems at all, and it will just work. But as I say, if you're using third-party libraries, so unfortunately all the third-party libraries that we're using internally, JSON is one that springs, for example. We didn't have any problems with it, but it's just worth trying it out to get an understanding early in your development phases whether you're going to have to do any work. Some apps just work. Our sample app didn't, and we had to do some work in order to make it function. So I'd really encourage you to do it. Any other questions? A very quiet bunch. Well, if you've got any other questions you want to come and talk to us about afterwards, then come and have a word with us here, and we'll be on the showcase afterwards for the next couple of days. So thank you all very much for coming along.